We're going to take a look at 2.3f, which is graphing using x and y intercepts. Okay, so we're going to use find just another way to graph these. So the first way was that we could put things in slope-intercept form, and we could plug numbers in, get values back. So we plug in a domain and get a range, do an input and an output. And that wasn't the quickest way, and so we wanted to come up with a faster way. And so we decided that we would put it in slope-intercept form, and we'd use the intercept and the slope. So we'd use what that form actually has available for us. And now the third way that we're going to look at it, and again, it's not the best way, it's not the fastest way, it's not any particular thing except for another way. Okay, so it's another way. If I needed to know where these things are crossing the x-axis or the y-axis, then I would use intercepts. And once I have the intercepts, or I know how to find the intercepts, then graphing it really is the next step that we want to be looking at. So we're going to be talking about x and y intercepts. So when I take a look at a graph, okay, here's a nice little graph. I want to know, what does it mean to be an intercept? So let's look at the y-intercept first, because we've kind of been working with that. The y-intercept, when we graphed it in slope-intercept form, we would go and we would go up or down on the y-axis, and we would put a point, and that would be our starting point. Well, that's really the y-intercept, and the important thing for us to remember about that is that that's actually an ordered pair. Okay, whether the y-intercept was there on this graph, or if it was up here, or if it was down here, okay, no matter where it is, I have some sort of value where I didn't go left and right at all, so I didn't move on the x. All I did was go up or down, and so that's an important thing to notice, is that the ordered pair is always 0 comma something. Okay, in each of these points, this is 0 comma 8. This is 0 comma 4. This is 0 comma 1, 2, 3, negative 5. And 0 comma something is always a y-intercept. And that's going to help us out algebraically when we are finding these x and y intercepts using some algebra. Okay, so the intercept is always a 0 comma something when it's the y-intercept. Well, similarly, the x-intercept, the x-intercept for this one is right here at negative 2 comma 0. If there was a graph that crossed through these 2 points, let's say like that, then I would have an x-intercept over here of 5 comma 0. Okay, I could have points over here to the left. Okay, that let's say that we had a line that crossed through there. Oh, that's not a very straight line. You should draw a better straight line than that. But the thing that I want you to notice is that the x-intercept there is negative 9 comma 0. Okay, notice that the y value is always 0 when we have an x-intercept. Okay, so keep that in mind as we go and are trying to graph these using those 2 points. So here's back to our problem. Okay, I don't have to solve this for y. If I wanted to graph it using slope-intercept, I would solve it for y. I don't need to when I'm finding the x and y intercepts. Okay, when I find the x and y intercepts, I'm going to do 2 different problems. So I'm going to do the x-intercept over here, and I'm going to do the y-intercept over here. For the x-intercept, we just talked about that the y value is always equal to 0. So let's take and substitute that in for y. So I'm going to have x minus 3 times 0 equals 3. That's x minus 0 equals 3. Well, x minus 0 is kind of redundant, so we get just x is equal to 3. Now that's an ordered pair. Y was 0 and x was 3. So x was 3 and y was 0. Okay, so the x-intercept is 3 comma 0. So I can put that on my graph, 3 comma 0. That's right there. The y-intercept, that was when x was equal to 0. Okay, so I'm going to take that same equation, I'm going to take this, and I'm going to plug it in for x. So I get 0 minus 3y equals 3, which is just negative 3y equals 3. I have to divide by negative 3 here, and y is equal to negative 1. So I get 0 was my x, and negative 1 is my y. So 0 comma negative 1 is the value that I want here. And now I can draw my graph in, and that's what my line looks like. Okay. We should put arrows at the end of these. I forgot to add the arrows. Put in arrows at the end of these because this actually goes on forever. We have all real numbers being the domain and range for these linear lines. Now, problem number 2 is already in slope-intercept form. So if you understand slope-intercept form and the directions didn't tell you to find the x and y intercepts, you could go ahead and graph this by using the slope and the y-intercept, okay? And that would be fine. Okay? The directions actually tell you to find the x and y intercepts. So we're going to find the x and y intercepts, and then we're going to graph it. Okay, so it's a little bit different than when the directions just were graph, because now it asks me to do something specific, so we're going to do that something specific. So let's do the x-intercept first. The x-intercept, I'm plugging 0 in for y, so I get 0 equals negative 2/3 x plus 1. Well, this is a nice friendly equation. I need to subtract 1 from both sides, so I get negative 1 equals negative 2/3 x. Part of us remembers, hopefully, that then when I'm solving this, that I need to get rid of the fraction, so I multiply both sides by 3. So the 3's cancel over here. I get negative 2x, x, is equal to negative 3, divide by negative 2, and x is equal to, the negatives cancel out, and I get x is equal to 3/2. So my ordered pair, I had x was equal to 3/2, and my y was equal to 0. And well, when I graph that, 3/2 is 1.5. Okay, so 1.5 is like right there. Okay. If it comes out negative, it would be on the other side. This is positive, so we're going to go to the right-hand side. So the y-intercept, we're going to plug a 0 in for x. So I get y equals negative 2/3 times 0 plus 1, which is y equals 0 plus 1. And that's just y is equal to 1. So I had 0 for the x and 1 for the y. 0 for the x and 1 for the y. It looks like that. And I can draw the line in. And my graph looks like that, going on forever, infinite domain and infinite range. So we look at these. We could have also done the y-intercept by knowing the fact that this is the y-intercept. Okay, this was in slope-intercept form, so it gives me the y-intercept without me necessarily having to find it. But I can find it algebraically as well. Okay, so if you have any questions on that, okay, make sure you ask them as we're going through this worksheet, naming the x and y-intercept, and then graphing it using those 2 points.